Hi everyone, my name is Ashton. So very excited to be here. So today we'll be talking about Xnode and Openmesh. So what is Openmesh? Openmesh is a decentralized cloud and Oracle network. So we provide immutable data, peer-to-peer compute and storage. We also have an element for big data and analytics. So the best way to think about Openmesh, we bring the best of AWS, Chainlink, and IPFS into one design, in one solution. So the best way I look at Openmesh is we bring the traditional infrastructure, like traditional cloud infrastructure, into Web3. Our goal is to accelerate Web3. So we have a very small team, so we started 4 years ago. So most of our team based out of Sydney. So the question we asked, why cryptographically guaranteed data and why decentralized infrastructure? So if you think about this chart, the technology is no longer double every 2 years. In our space, in Web3, technology doubles sometimes every month. So, but what's the problem? The problem personally, if you think about the world IT and infrastructure, is controlled by 3 to 4 companies, and we're supposed to trust them. If you think about a couple of years ago, these very same companies, they control pretty much a lot of data, and they had the capabilities to do like a read and write capabilities to fabric of society using social media, all the apps they provide. Now, what concerned me the most, the very same companies, they also happen to have the majority of the AI capabilities. And they're all in a race to compete each other to show who's bigger and better. It's no longer innovation, it's about politics, sometimes it's about Wall Street narrative. But if you think about this, if you project this into another maybe 50 or 100 years, right? The question we have to ask ourselves, if we move from type 0 civilization into type 1 civilization, the same companies will have like a mega corporations controlling the entire solar system, right? The data infrastructure will be controlled by these corporations, and I have a big problem with that. So that's why I drawn into decentralized philosophy. I got into Web3 back in 2015. I used to run a meetup, Ethereum meetup and Bitcoin meetup here in Sydney and Wollongong. So if you look at the design principle we choose, so we got to have a good design, because if you don't get the design right at the beginning, it's going to be it's not going to be a good thing. So I don't have much time, since we have only 10 minutes to cover the core infrastructure, but I'll keep it very high level because I wanted to show you some demos for our hackathon, so you guys can take a look at our technology. So I'll talk about Xnode. So just to be clear, Xnode is a one product. We've got about 14 products that we developed, all open source. All designed for developers. So we've got APIs for developers to power applications. We have infrastructure as a service, which is Xnode. And then we also have analytics and big data, specifically for Web3 space. Now, what is Xnode? So Xnode basically aggregate all the physical infrastructure, available infrastructure, from bare metal providers, from cloud infrastructure providers, and also independent resource providers. These resources are GPU, storage, and compute. So we bring that and we deliver that to the developers. So developers can quickly design, deploy, and manage infrastructure very, very quickly. The difference between going through AWS and GCP compared to this approach, you have a full control of your infrastructure. Ultimately, you own the infrastructure. I'm going to do a quick demo of this Xnode platform. Again, this is still in beta, so there will be a lot of bugs. So if you think about like infrastructure development space, we took a lot of inspiration. So this is the platform. So you have a website where it's similar like a Shopify for infrastructure. You've got a bunch of templates. So if you want to run a Web3 node, simply you pick a node, pick a template. So these are all modules. So you have a Web2 and Web3 infrastructure in this page. And then on the left-hand side, you've got lots of tools you can access. So from infrastructure to data to if you want to connect with third-party applications, all in one place. So let's say you want to run a Phantom node. You pick a template, and then it gives you information about what that package look like. So now when you select a provider, so it's similar like Skyscanner or Google Flights. Like if you say, I want to fly from Sydney to New York, find me an airline. So this is what happens. So what it does is basically aggregate all the bare metal providers available resources for your specific infrastructure. It just provides that like a list. And then what you do is you simply select. So it's selecting a server for your Phantom node, and you just hit deploy. When you want to deploy, it gives you a kind of a rundown of your summary of your build, and you can just go and build that directly into your bare metal provider. Either whether it's a bare metal provider or if you're using your own infrastructure, you can do that. Here, if you look at here, this section, if your server, let's say, if you use for a specific number of compute and specific number of storage, and if you have leftover from your server, you can rent that into a marketplace. Since we don't have much time, we'll skip that part. But the idea here is you can deploy infrastructure very, very fast, and you can save cost. To give you an example, if you were to run Ethereum node on AWS, you might be paying $600 a month. So with this approach, you can save up to like 50–40%. So you deploy it, and then you connect with the provider. Within few minutes, you have your infrastructure up and running. So this is a great innovation for infrastructure as a service use cases. So we've got use cases for running RPC nodes, where you can build infrastructure. For Web2 infrastructure, you can combine Web2 and Web3 infrastructures together. So it's a really nice way to build things very, very fast. And also you only pay for bare metal providers, bare metal services, so that way you can save time and money. So I'm going to hand over to Jay, so he will talk about a little bit more behind the scene of Xnode. Thank you.
Well, welcome everyone. Again, as Ashton said, my name is Jay. Let me actually, I was going to come around the podium and say hello, because I brought this, and well, you have microphones here, and I'm not mic'd up, so I'll stay right here. Welcome. You'll forgive me. This is actually my first presentation, in large part, especially, and I'm glad it's here at ETHGlobal, here in Sydney. Recently, how long has it been, Ashton? 3–4 months since I joined Openmesh? Yeah, oh, he's quiet now. So I've actually been, in large part, leading the engineering team there in terms of the infrastructure. Today we're going to cover Xnode OS. There's a huge number of systems and designs, from core validator to the peer-to-peer network, but we won't be covering that today. We're actually going to do a pretty high-level overview of Xnode OS, building applications on it. Obviously, this is an early preview. Everything is subject to change. Now, it's important to note that Openmesh is through and through open source. And so, well, what you're seeing here is an early preview, and if you looked at Openmesh's GitHub, you won't find some of it. It'll all be going up there as we lead to Genesis and move forward. So, again, just a basic I can't see that. And I'm not going to mess with the display. So, all right. Well, good to see that. That is also not working, because that's huge. Great. Isn't this always the way? Um, there we go. No, that is not working. Great. It just works until it doesn't. Yeah, sorry about that. You know what? We'll just continue, and I will, well, like we can't. What resolution is this? I wish I could have duplicated the venue so I could have tested this before I go to production. You know what? We'll bring this over and we will rely on. Is that showing up? All right. We'll go with this, I hope. Okay. So now we're back. All right. So where was I? Openmesh is open source, and I am over time. Okay. So there you are. There I am. There any developer is. Ashton mentioned Studio console. Studio is the application that you saw Ashton go through templates with. This is a standard web application. You'll be able to self-host it. Same thing with console. Console, obviously you have Xnode, right, which is an individual server. Bare metal or cloud. Console is responsible for deploying the Xnode image that is built. We'll go over how we build those here. So, Studio, there is a packaging repository which lives up on GitHub or wherever else you'd like. Generally, the console would point your Xnode to whichever packaging repository you would like to use. In that case, that points to all of the various use cases that we have on Studio, Pythia, various other applications, Geth nodes, etc. And then obviously there's the settings repository, which represents your individual Xnode. These things will all be version controlled, signed, using standard Git infrastructure. Studio and console both make that easy to use for users who are maybe less experienced with the underlying technology, but the whole system is well layered so that you can reach in and do what you have to do. Getting back into Xnode OS. Now, obviously, building your own OS from scratch is nonsense. Because Openmesh is open source, we like to also use open source and give back to the community. Therefore, Xnode OS is based on NixOS as its primary source, in the same way that Ubuntu uses Debian for its source. We use NixOS. We contribute back to it. And in fact, if you'll note that in the hackathon this weekend, we have 2, I believe, packages to be built for the NixOS OS package system that we'll then be able to use on Xnode. Okay, so we've covered Xnode OS. Let's go ahead and cover the agent. The agent is essentially a Python application that runs on every Xnode that goes and grabs configuration from the settings repository, which can be hosted at any appropriate Git repository location, including IPFS with the Git IPFS backend. And in fact, one of the things we're working toward is building Nix and Xnode OS entirely from source and entirely from IPFS sources as well. Back to agent. So agent will go ahead and pull both the settings and the package repository. We'll pull them in and then merges them into its local repository so that everything is auditable and you can see exactly what's going on. If you're not familiar with NixOS, it's essentially a functional operating system and package management suite of utilities, so that when you pair it with Git, it allows you to have essentially fully auditable all the way down to source deployments, which can be rolled back. It also actually handles dependency management as well. So you can have multiple applications installed on your Xnode at once, each one of which brings along its own dependencies. So for example, you can have just say a particular application that uses a different version of libc than another. Basically, the only thing that's shared on the system is the kernel, and if you're running an application inside a VM, that doesn't even need to be the case. Xnode OS is essentially a layered set of opinions. So initially, what you basically have is just system services, which is the Nix build suite, appropriately opinionated for Xnode and Web3, it's like with IPFS support and various other things built in, and also tuned to run core, which we'll touch. Core is is essentially Go application, which maintains the libp2p infrastructure, public and private unified data APIs. Again, I wish I had more time, or we wouldn't go into it. How am I doing on time? I've kind of lost track.
No, it's okay. There's no one following you anyway, so.
Oh, well, that's convenient. Plenty of time for questions. I'm sure I haven't done a terribly great job of explaining a lot of it. Apologies. System services, we've touched on core. So your application. Generally, what we'll do in Xnode OS is, right now, we're starting out with essentially a base system. Nix OS uses systemd internally. And so when you deploy an application, if you're deploying it to the bare system, you'll be writing systemd units. But you'll be configuring those through the Nix OS or Nix configuration language, which we'll touch on in the next slide. Well, the next set of slides anyway. So with all of this infrastructure around your application, which actually manages like your storage and does administration and cryptographic signing and validation of integrity and distributing your application over IPFS, et cetera, we'll actually look and see how you would, say, build Xnode and how we build Xnode internally. Again, oh my goodness, I'm sorry. That is not going to zoom in. Where is that? So this is actually one of the configuration files for the ISO image that we build for bare metal servers. Actually, now I can see it over here. In this stanza, basically this is just Nix packaging language. We utilize Nix OS generators, if you're familiar with that. If it's not, it's a suite. If you're not, it's a suite of utilities and functions which allow people to easily build system images for either install or running out of, say, memory or anything else on, say, like DigitalOcean or AWS or, you know, any bare metal or cloud provider. Major one, GCP. Anyone else? Currently, we're doing ISO. We have a number of things. If you look at if you remember Ashton, you'll see a number of logos there. All right. So again, this is essentially just the ISO module. The ISO module actually includes all of the configuration required for the utility suite to build this ISO image. We include configuration, which has documentation. I'm not going to read out the whole thing for you, but we disable the documentation. You can see here we set the system greeting. That needs to change, and then the system label. And so, doing configuration for all of these various system utilities is all in one file, all in one case. If we need to split it out, obviously there's includes, but for things that change together, they stay together instead of being split across a whole bunch of different files in the system or with some bespoke build suite. Yeah, so again, ISO image, force text mode, make bootable. That's that. Building the image, you essentially just, there's a make file, or you can just do Nix build. And there's that. Goes through there, and then you get the ISO image. Coming back here, once that's built, that gets deployed back out to your cloud provider. We have the, okay, so from the console, those images get deployed. The console essentially has a set of event hooks and uses state machine replication. So when you use your console instance, it essentially manages the life cycle of your servers. It's stateless, and it follows the Kubernetes operator design philosophy, where the particular executable maintains no local state of its own. It's just listening for events from various cloud providers. Like, say your VM's gone down, you need to spin up another one. Just various other things.
5 minutes.
Thank you. Yeah, I appreciate that. Cool. Obviously, going up here, you'll need some way to get information from your application package into Studio, which is through this, again, this packages repo. Studio will read in description files. I've gone out of order. All right. So again, if you're familiar with the Studio, which Ashton showed you, it's essentially a UI set of applications to configure. Well, it's a lot more than that, but in large part, as it relates to Xnode, the Studio allows you to change and modify configurations of templates and packages that you have deployed into your Xnode. Obviously, to do this, you need some sort of a schema to describe the UI that you want in Studio. One of the things that we are experimenting with at this point and have started to integrate is descriptions of UIs using just simple JSON generated from specific files in your package out of your Unix package. And this is actually just an example for Geth. And if I hadn't gone out of order, I would have already introduced. I would have introduced this. So essentially, this is the Geth package from Nix packages. You have essentially just a set of Geth instances, and that lists options. So enable, make enable option, go Ethereum node. It's all quite self-explanatory. Okay, so configuring system services. Now, one of the things that your application is obviously going to have to do is it's going to have to spin up system services. Your application server, like say if you're deploying K3s to your Xnode, just to use an example, you would have to spin up the various K3s daemons and run it. Again, this is obviously from the Geth deployment. So you would essentially, for each Geth, you just go through, you set the system packages, which includes the Geth name for the configuration. And then for each Geth instance, sets the state directory, sets the data directory, sets it into system services, and then just basically creates ordering targets. And that's what you have to do to generate a new systemd service instead of writing a whole bunch of unit files. And in this case, you'd be configuring it with Xnode console, which would then also go into your system configuration as well. We went over that. So system service instantiation. If you want to say set up a Geth node that does Sepolia, you just have services, Ethereum, Geth, and Sepolia, and then you just set the configuration options that we defined earlier. This is actually quite straightforward. So if you note that like this IP address, if you there we go. If you look at the IP4 CIDR here, that comes from there. And that gets rendered down, obviously, into this configuration language. It's that. And so packaging existing blockchain technologies for Xnode is actually, it's quite straightforward. If there isn't already a Nix package for it, then it would be available really quickly. And as I said, like with the hackathon this weekend, we'll be bringing several applications into Nix and thus Xnode as quickly as we can. And this also gives us a very large community of people who are already, used to developing these systems. So yeah, thank you, MJ.